For lesson 8-1, we're going to be simplifying algebraic expressions. Remember, the word expression gives us a clue that we will not have an equal sign. So it's more or less just kind of getting the expression simplified as far as we can. You may see multiple common variables, and we're going to combine like terms and things like that. So getting into some of those words, equivalent obviously just means equal to. When I say combine like terms, so like 3a, negative 2a, a, and 6a, those are all like each other. So if I were to combine all of these, I would have to know what is the coefficient of a. Remember that 1 times a equals a. So whenever you just see a, really it's just a positive 1. Same thing if you have a negative a, that'd be like a negative 1a. So if we're going to combine all of those right there, what I would probably do is combine all my positives first to make 1 plus 6 is 7, plus 3 is 10, and then 10 minus 2 is 8. So I would be left with 8a when I combined all of these like terms. When I talk about constants, the constant, if you think about y equals mx plus b, b is a constant because it doesn't ever change. You know that it is the y-intercept of that equation. So it's a number that won't change. Whereas like 3a, that is not a constant because we can plug any number in for a and you're going to get a different value all the time. So therefore it's not constant. Simplest form would just be what happens when we actually simplify the expression. You know, like 4 halves is equal to 2. That, you know, will be an example of simplest form right there. So use the distributive property to rewrite 3 times the quantity x plus 5. Okay, and that's how we read that. 3 times the quantity x plus 5. So right now, since I have a variable in here, we wouldn't call this simplest form. We would actually distribute this 3 to be 3 times x plus 3 times 5, which equals 3x plus 15. So that'd be how to show the work on how to distribute this, to copy the problem down, show these arcs that you're distributing, rewrite the problem. Notice I didn't just multiply it in my head, I wrote it out, and then finally I can simplify it. So now I don't have to do 2 steps, I just got to plug the number in and solve. So again, a plus 7, I would say the quantity a plus 7 times 7. So even though it's written a little bit different here, the numbers at the end, we do the same thing. So we're going to distribute this 7, so we have 7 times a plus 7 times 7, or 7a plus 49. Okay, so that would be this expression in simplest form. Okay, how did I determine that I was going to add? The addition symbol comes from there. Okay, same thing from before. I was adding before, so I'm still adding now. Okay, if I would have been subtracting, the subtraction symbol would have come down. So 2q minus 3, okay, the quantity 2q minus 3 times 9. Again, I'm going to distribute that 9. All right, so this would be 9 times 2q minus 3 times 9. Okay, a little bit of order of operations here. 9 times 2 is 18. Q minus 27. All right, now, so I have a variable term here and a constant here. So that means I'm done. I can't go any further because I don't know what this q is. And order of operations says that I have to multiply before I subtract. So I can't really do anything else. All right, so negative 3 times quantity z minus 7. Again, we're going to distribute negative 3 throughout. So negative 3 times z. All right, and now here it kind of gets a little tricky because we're doing, you got to remember that this is a negative times a negative, okay? So negative 3 times negative 7, we're actually going to get plus 21, okay? Another way to kind of maybe avoid that here is you can just say negative 3z minus, and then do negative 3 times a positive 7. And when we do that, then you would get a negative 21, and you notice we have 2 negatives in a row, which would be an uh-oh, we'd have to fix it anyways. So again, Think of subtraction not only, yes, it is subtraction, but think of it as a negative. So -3, and this is -7. All right, once you get to this point, -3 times z plus 21, then we are in simplest form. All right, so identify the terms, like terms, coefficients, and constants. Simplify the expression. This is the part I'm interested in. Simplify the expression. So I have 3x minus 5 plus 2x minus x. Okay, remember the coefficient of this is 1. Okay, so what I would do here is I would combine my positive x values first. So right now I have 5x. I'm going to move this variable closer, so I have minus x, and then I have minus 5. Okay, the reason I could do that is because I am thinking of all these as being additions, so it would be like plus -5 and plus -x. Okay, when I think about it like that, I can move around however I want because addition is commutative. Okay, so I can add that in here too. I'm adding. All right, and then I can have them in any order. Now I'm going to combine my 5x and my -x to get 4x minus 5. All right, and now I'm in simplest form. See, this looks a lot cleaner than what we had to start with. All right, so now once I tell you, okay, x is 2, you can plug in 2 and solve that pretty quick. If I gave you this equation and I said x is 2, it's going to take you a little bit of time to work everything out. So it's a lot easier in simplest form. Simplify the expression. 6n minus n. Well, that's simply 5n. All right, it'd be like you have 6 notebooks and you're going to take 1 notebook away. Remember, the coefficient is 1. So basically 6 minus 1 is 5. And that'll work out. Obviously, 5n is a lot easier to look at than 6n minus n. So again, simplify. So I'm going to combine my positive variable expressions. So 8z and z would make 9z. Okay, I'm going to move the, I'm going to say plus negative 9z next to it. And then I'm going to say plus 2 and plus -5. So that took care of everything else. Now I notice here I have 9z and -9z. Well, those are just going to cancel. That'll be 0. Okay, so then 2 plus -5 would be -3, and that is my final answer. So I was able to actually cancel out my 9z and -9z. So we don't actually even need those in the expression at all. They're not going to be there. Our final answer is -3. Tickets for the school play cost $5 for adults and $3 for children. A family has the same number of adults as children. So write an expression in simplest form that represents the total amount of money spent on tickets. Well, normally I would say 5 times A plus 3 times C. So 5 times the number of adults plus 3 times the number of children. But in this case, it tells us that a family has the same number. Same number is key. So I can just do 5 tickets plus 3 tickets. Okay, and then when we combine that, it's going to be 8 times t, and that'll be the total cost of all of our tickets. Tickets for the museum cost $10 for adults. So if I was going to write that, it would be 10A plus $7.50 for children. A group of people have the same number of adults as children. So write an expression in simplest form that represents the total amount of money spent on tickets to the museum. So again, I can just say 10t plus 750t, and we can add that up to be 1750t, and this would be my final expression there to represent how much money we're going to pay to get into the museum. That was our last example for today. Be sure to check the answer key for the worksheet if you have any questions.